I'm Jess. Thank you for having me today. I'm going to talk about performance with React. But who am I? I'm Jess. I got a job in a startup about 6 years ago, and that's what got me interested in programming. And then eventually I quit my job to do a boot camp, and then I took part in Rails Girls Summer of Code, which is a really nice fellowship for female developers. And I've been working as a developer for about 2 years now, and I work for FutureLearn, which is a digital education platform. One more thing about me is that I like drawing pictures of fish. This is an eel, and I like eels because I'm from Cambridge in the UK, which is close to this marshy flatland called the Fens, and that's where eels thrive. But what are we going to talk about today? Virtual DOM and reconciliation, how to test the performance of your app, should component update, pure component, React Memo, hooks and performance, array modification threats, windowing technique for long lists, React lazy and suspense, and analyzing your bundle. But what is performance anyway? Performance is a huge topic. It depends on many factors. For example, the hardware that your user has and the connection speed that they have. But as front-end developers, we can't do much about that. But what we can control is how big our front-end bundle is, how it loads, and in React, we can take steps not to render or re-render unnecessarily. These are Mozilla's web performance guidelines. An initial page load should be between 0.5 and 2 seconds. A response to a user input should be between 50 and 200 milliseconds. And anything that takes longer than 1 second to load should see a loader or a progress bar until it renders. In most browsers, in most devices, the browser will re-render every 16.7 milliseconds. That's the same as 60 frames per second. So for scrolling, transitions, and animations, there should be a re-render every 16.7 milliseconds. But in practice, a re-render every 100 milliseconds will still feel responsive to the user. This is because of the way our minds perceive movement. That's the same as 10 frames per second. But if there are animations in your application which take longer than 10 frames per second, the user may experience jank. What is jank? Great question. Jank is defined as stuttering, juddering, or just plain halting that users see when a site or app isn't keeping up with the refresh rate of the device. Who cares? Who cares about this stuff? Why should we care? I'm working away on my React components. They look good to me. What's the big deal about performance? Well, the thing is, we're all developers, designers, project managers in this room. We probably work on a really fast, fancy computer with a great connection speed. But the majority of your users probably don't. And that means that they're going to notice performance things that you don't. Also, most users of the web are now on mobile rather than desktops. And the average user has a mobile that costs less than $200 US. And they might even be on like a really slow 4G connection or something. But I thought React was fast. You're right, React is fast, but the reconciliation of the virtual DOM is expensive. What is reconciliation? React limits the direct manipulation of the DOM by maintaining a virtual DOM. And then any update to your site triggers a reconciliation between the old and the new virtual DOM. And this reconciliation process happens even if there's no change in the user interface. So it's best to avoid re-renders wherever possible. What is the virtual DOM? The virtual DOM is a JavaScript object that React builds to maintain a representation of the user interface. It does this to make sure that React only updates particular DOM elements when it is necessary, when something changes. And this is what makes React fast. Let's imagine that all of these are React components. C1 is the container, C2 and C3 are the children of C1, C4 and C5 are the children of C2, C6 and C7 are the children of C3. Imagine that something changes in C1, some state update happens or something. Which of the children will re-render? All of the children will re-render. If there's a change in the parent, then all the downstream children re-render. And what if there's a change in C2? Which will re-render if there's a change in C2? C4 and C5 will re-render because they're the children of C2. So every component is re-rendered each time an update happens to its parent. But what if there's an update which doesn't change any of the children? This would be a wasted re-render. Now let's see an example. This is a site which displays some data about animals in a table. There's a parent component called table, then children components, header cells, rows, and cells. If you update the theme with that button on the corner, then all the components re-render. Now I'd like to introduce you to Why Did You Update? It's a package which logs to the console when potentially unnecessary updates occur. It's really easy to install and use. You just npm install it and then call it in your root file. And then it will log the potentially wasted re-renders in your console. Now if we change the theme, as you can see, the app is re-rendering a lot. There's a lot of wasted re-renders here in the rows and cells. Nothing is changing, but these re-renders are happening. I'd also like to talk about React Profiler, which is part of the React DevTools Chrome extension. You can measure the speed of your React app. You just select the Profiler tab, click Record, and then make an update to the UI of some kind. Then you can see how long each component takes to load. In React Profiler, we see the two phases where the update happens. The render is where the reconciliation happens between the new and the old virtual DOM and determines whether or not the UI should be updated. And in the commit phase, React implements the changes to the DOM by updating, removing, or inserting elements. And it's the whole start-to-finish process of updating the browser window. Here you see a visualization of how long each component took to load. The slowest is at the top and the fastest at the bottom. So let's have a look at React Profiler for this example animals app. Let's click the Profiler tab, then record, make an update, stop recording, and let's see what happens. It's very similar to Lighthouse on the Chrome DevTools. In this case, the commit is 2.3 seconds, and the render is 7.9 milliseconds. So let's see if we can make it faster. If you want to avoid wasted re-renders, you can use should component update. Should component update returns true or false for certain props. If you know that in some situations your component doesn't need to update, you can return false to avoid a wasted re-render. Imagine that C2 is a component with should component update in it, returning false. What happens if there's a change in C1? Which children will we render? Thank you. Yeah, OK. So C2 has should component update returning false, so it doesn't re-render, and neither does its children. But C3 and C3's children do re-render. So this is the structure of the animals app that I just showed you. If we put should component update in the row component, we don't get a wasted re-render there or in the cells. We could also put should component update in the table, in the container component. Then you'd avoid wasted re-renders in the header cells, the rows, and the cells, blah, blah, blah. But the thing is, you might get a bug if you add props later and then wonder why they don't update. So it does have some drawbacks. Maintaining should component update can be hard. Like I said, if you add a prop but forget about it, then you might get a bug. And also, the performance gains from should component update are often quite insignificant. So you should only use it once you've observed that it provides a measurable performance improvement. Another thing you can use is pure component. You can use pure component instead of the regular React class component, and then you don't need to write should component update methods, because it uses should component update under the hood. If a prop changes, it will trigger a re-render. If no prop changes, it won't bother to re-render. So pure component is listening out for any changes and will only re-render if something changes. It does a shallow comparison of the props. So if a prop is an object that has one of its properties change, then a re-render won't be triggered. But what is a shallow comparison? Imagine we have three different objects, x, y, and z. X and z contain the same key value pairs. y is different because yb is 3 instead of 2. So y is not equal to y is not equal to z according to shallow comparison, which is what we'd expect. But also, x is not equal to z, because even though they have the same key value pairs, they have different variable names. And if we change y so that yb is 2, even though it has the same key value pairs as z, y is not equal to z according to shallow comparison. However, if we reassign y to z, y is equal to z. And if we then reassign yb to 3 again, even if yb and zb are not the same, the shallow compare will treat y and z as equal, because it doesn't look at the key value pairs. You can use a pure component for the table container component to stop re-renders downstream in the children. There are also some caveats to pure component, only for class components, and it implements should component update with this shallow comparison. Also, you should be careful when using this props.children, because when React compares new and old children props, the child component is always returned as a new object. So React might assume that the children should update when perhaps they shouldn't. But what about functional components? React Memo can be used for stateless or functional components. It's a higher order component, and it can give a performance boost by memoizing your component. That basically means that it stores and caches the result of the component so it doesn't re-render if the parent updates. It's similar to pure component, but it's only for functional components instead of classes, and also shallow compares. What is memoizing? In computer science, memoizing is a technique used to speed up programs by storing the results of an expensive function call and returning the cached result when the same function is called again. So header cells, rows, and cells can all be memoized since they are stateless or dumb components. Let's test the animals app again. When we click the Update Theme button, Why Did You Update is not logging any wasted re-renders. And in React Profiler, let's record the theme update again and see what speed we get. OK, so the commit is 0.5 seconds, and the render is 1.1 milliseconds. Let's compare with our first measure before we had the pure component and React Memo. The commit, which is the actual process of updating the DOM, is 0.8 seconds faster, and the re-render, which is the reconciliation process, is 6.8 milliseconds faster. Also, this was a simple example application, but imagine a huge application with a huge list of data and a user with a mid-performing smartphone, and you're on a slow connection. And it might make more of a difference. There are also some caveats to React Memo. It's similar to using should component update, but it's always set to false. Although this can be adjusted if you provide a comparison function as the second parameter. In this example, the function r_equal checks if the props have changed. If pref props are equal to next props, then it returns true. And the memoized value is returned. You can use it on components with children, but make sure they don't have props which should change. But what about React hooks? What do they mean for performance? So hooks don't actually add any new functionality, but there are some performance benefits to using hooks. This is because functional components tend to minify more efficiently in the bundle. In class components, the lifecycle methods are not minified, and unused methods are not removed from the build. The useMemo hook allows you to memoize the results of a function and will return that result until an array of dependencies change. In this example, the component receives a list. The list coming into the component has an expensive function performed on it. Unless something in the list changes, the result will be memoized and the expensive function will not be rerun. The hook useCallback can also help performance. The difference between useMemo and useCallback is that useMemo calls the function, returns the result, and useCallback returns the function uncalled so you can call it later. So useMemo returns the value, and useCallback returns the function. Okay, maybe you've had enough of methods and hooks now. What else can you do to improve performance? Another thing to watch out for with React is when you have lists. When you create a list in React, you should provide a key for each item in the list. They allow React to identify which items have changed, or added, or removed. It can be tempting to use the index for the key. Index refers to the position in the list, first, second, third, etc. But this might cause problems if your list is going to change. So it's better to use a unique ID for your key. This is because if the list changes, for example, if a user can delete an item in the list, it means that the index will rearrange. So if you're using the index as your key, this rearranging is going to have a performance impact. There's also the windowing technique for lists. It's also known as virtualization. And it improves the performance of long lists of data by only writing to the visual portion of the list to your DOM. Because if your application is rendering a really long list of data, you have to wait until the whole thing loads before rendering the first item. But if you use this windowing technique, you only render a small subset of your rows at any given time. So it'll just render the first few items, then load the rest. And there are two main libraries you can use. React Virtualized was there first, and it's a bit larger and has more features. And React Window was created more recently, and it's a bit lighter. So here's an example with 300 items in a list. The non-windowed example on the right, the list takes longer to render, but it scrolls very fast. And with the windowed example on the left, the list is faster to render, but it scrolls more slowly. The other problem with a big React project is that it'll often have a large bundle of JavaScript with lots of libraries, and that's going to take a long time to load, and it'll slow down your app if it all needs to load at once on the first page render. To mitigate this, you can start splitting your code and then lazy load items as and when they're needed. While a lazy loaded component is being fetched, you can use suspense to render a fallback component. The fallback prop accepts any React elements that you want to render while you're waiting for the component to load. In this example, a loader is passed into the suspense component as the fallback prop, while the component you see at the end is being lazy loaded. Another great tool for analyzing your application's performance is Webpack Bundle Analyzer. All you do is npm install it, add it to your Webpack config file, and then run your application in production mode. And it'll give you this visualization of your bundle. Some things to watch out for here are what are the largest dependencies or libraries? Maybe there's a more lightweight version you can use. Maybe there's a library which is duplicated, or maybe there are two libraries that basically do the same thing. For example, maybe you've got both Moment and DateFNS. Maybe you only need to use one of them. There are also some other micro-optimizations you can make. Fragment helps you avoid creating unnecessary divs. Remember to use the production build of React on production because the build is smaller. And resize images to the minimum size. Okay, now is the time to wake up if you fell asleep. What do we look at today? Virtual DOM and reconciliation, how to test the performance of your app, should component update, pure component, React Memo, hooks and performance, array modification threats, windowing technique for long lists, React lazy and suspense, and analyzing your bundle. And some key takeaways from this talk are before making performance improvements, use React Profiler to test performance. Use why did you update to check for unnecessary or wasted re-renders. Should component update can stop wasteful re-renders. Use pure component in class components or React Memo for functional components, and test before introducing performance improvements. And that's it from me. Thank you very much.